This is Philosophy 205, Files lecture series, Forum in Ethics, Law, and Society. And we have today Ron Chrisley going to talk about generative AI and mental imagery. Ron is a professor at Sussex University in cognitive science and artificial intelligence. And until yesterday, he was one of the co-founders of 10x. It was acquired by, what was it acquired by?
Salesforce.
Salesforce. Oh, so that's really cool. And so, you know, Silicon Valley success story, right? So I'll let him tell you some more about that. All right, so let's give a warm welcome to Ron Chrisley and get started.
Thank you. It's a pleasure to be here. Thanks for making that possible, John. And also thank you all for showing up. It's really a luxury to have so many minds, the attention of so many minds to discuss these issues with. So I probably won't say much more about the acquisition of 10x by Salesforce. Just say I'm not going on to work at Salesforce. I'm going to go pivot back to academia. Oh yeah, welcome to you, my virtual friends. Glad you're here too. Okay, so I want to. Oh, this happens all the time. I'm sure you've had your own discussions. You've seen the discussions. They go on and on about these, in particular, LLMs like ChatGPT, but also the other big models that we've been blown away by, perhaps, for instance, like Midjourney, DALL-E, the models that generate images, for example. And you've heard other ones, seen other ones, I'm sure, like ones that generate music, etc. The big issue that often arises when people start discussing these models is, well, maybe they can behave as if they understand what's going on to some limited extent, but do they really understand? And one can be sympathetic with that second point of view, being skeptical about whether they really understand. First of all, because they might get the answer wrong in some contexts. So just because they get the answer right in some contexts might lead you to think, wow, they're really understanding what's going on here. We really have AI, we have AGI in our time. We have super intelligence maybe in our time. That's really impressive. But then you see that you ask one of these same model a real softball question, easy question, and they get that wrong. And you realize, okay, or you begin to wonder, when they were answering the first question, maybe it wasn't because when the model was giving an answer to the first question, it wasn't because it understood so much as it's the statistics that it collected about, say, English language use led to a good answer. But here, the incorrect answer suggests that just collecting those contiguity semantics, statistics, just the statistics about what words are next to each other, and therefore what word is most likely to follow given the words that have been seen so far. Just collecting that data and learning to make a generative model from that data, maybe that's not enough to understand what the words in the data were talking about. And so this question goes back and forth, and the debates go on and on. And what I wanted to do was try to address, look at a different kind of competence that isn't usually looked at with these models, to get a different angle on this question about whether the models are really understanding. And what I wanted to do is, instead of focusing on questions having to do with, well, capabilities involving text to text, say, asking a question and seeing what the answer is, I wanted to focus more on the case of image understanding. And I don't mean just image classification, or even, as in this case, incorrect or correct image generation. I mean reasoning with images, doing imagistic reasoning. So that might be unclear about what I have in mind. So what I'd like to do is start with, after that long intro, start with some audience participation. So I'd like you to all engage in this activity to find out whether you are a as say a normal human subject with statistically average mental imagery capabilities, or whether perhaps you might be, and this is okay if you are, aphantasic, that is limited. You might be a person with limited mental imagery capabilities. So here's this is not, I'm not giving a proper psychological diagnosis of you here. I'm just giving you a task now that is indicative of which you might be. So there's this classic study from Pinker, yes, the famous Steven Pinker, and Martha Farah. Let me move this window I have here so I can see what. So it's this classic study where people were asked questions, where they were asked to do things in their head without writing anything down on paper. So in their head, they were asked to imagine various things, and then they were asked questions about crucially, perform transformations on those things in their head without using any external props. And then they were asked questions about what they saw in their mind's eye in the resulting image after those transformations. So a simple one and a very indicative one is here. So I would ask you all now to join with me in this process. I want you to imagine the capital letter D. Now I'm cheating a bit here because you can see a D there, so that's kind of maybe helping you with your imagistic operations here, but try to minimize that. So you could do this with your eyes closed if you like. I can just give you the instructions, and then you can at the end I'll just ask people to raise their hands. So imagine the capital letter D. Now imagine that capital letter D, but rotated counterclockwise 90 degrees so that we would intuitively say it's lying on its back, okay? Now imagine that figure that you've just created through that operation resting on top of a capital letter J, resting above it. So the J is below in the resulting image, and the rotated D is above and on top, and they're just touching. And the D maybe is situated just, the back of the D is centered on the spine of the J. Okay, now if you've done that, the question I want to ask, and don't shout out the answer, is can you detect a common pattern in the resulting mental image? Does that resulting mental image resemble any kind of everyday pattern or everyday object? And if you are pretty sure that you know of such a pattern, raise your hand. Okay, so I'd say there are a majority of you who feel confident, and I would say there are a sizable number of you who don't feel confident that they could identify a common everyday pattern in that. So let me take one of the people who did feel confident. Can you shout out loud, what it is that you saw in your mind's eye? Umbrella, right. So for a lot of people, it's not only is there an answer, but it's kind of a clear, obvious answer. Now, for those of you who didn't raise your hands, do you now see that that image that you're asked to construct could be understood as an umbrella, or are you still puzzled? How many of you now see why umbrella could be a good answer? And how many who didn't raise their hands initially still are unconvinced that that's actually a good answer or don't see why it is? Okay, so there's a kind of recognitional ability that you might have, even if you don't have the ability to construct a classification of that mental image yourself. When presented with a set of answers, you might be able to select the right one, the one that the majority came up with, by recognition rather than by having to generate the idea yourself. Okay. Now, one question is, what about our AI? I won't say friends. What about our AI, the AI models that we're building? What's interesting about this task is it's an entirely, in a sense, a linguistic task, because all I did was say words to you, and okay, you raised your hands, but I could have had you say words back. So yes or no, or umbrella, or trash can, or automobile. You could have said any of those things back. And so in a sense, it's really a text in, text out task. Now, intuitively, we think that even though it is behaviorally a text in, text out task, what's going on that enables you to correctly answer the question is something that isn't entirely linguistic, but intuitively, there seems to be some kind of internal mental imagery processing going on. But at least as far as a computational task, it is, strictly speaking, text in, text out. So you can take these purely text in, text out generative models and ask this question of them. And let me just say something here. I'm kind of torn. Like a lot of people, I'm interested in what the models that we have now and models we develop in the near future, what they can or cannot do, and when do they fail and when do they succeed, and can we make sense of when they fail and when they succeed. But I think just as important, or perhaps more important, is not, does GPT-4 solve my pet mental or whatever reasoning task correctly? Aside from those particular questions, I'm interested in the more general question, especially when we're talking about mental imagery. What would, when would it be correct? On what grounds would we correctly attribute mental imagery or the capacity to reason with mental images to a system based on its behavior? Is there a right answer to say, if you behave this way, then yes, you do, you are, you do have this, you meet the sufficient conditions for being a reasoner, something that reasons with mental imagery? Or is it not purely behavioral? Do we have to appeal to something about the mechanism and say what kind of mechanism it has to be? Like it may be understood in a computational terms or functional terms. Or do we have to go so far as looking at the implementation, say only if it's made out of biological stuff does it really do mental imagery? If it's not made out of biological stuff, then it's not really doing mental imagery, no matter what computation it implements and no matter how well it performs. You might imagine from the way I put that I'm very skeptical about that last approach. That I get frustrated when I meet people who have that that point of view, and it's a very common view in cognitive science nowadays. But I tend to be more on the functionalist computational level and think it's not just behavior that has to be right, but if you generate the behavior for the right reasons, that is by undergoing the right kinds of computation, then it becomes harder and harder to, for principled reasons, to deny the ascription of, say, mental imagery processing to that system. In particular, it's not just the computational states that are used or the algorithm used, but also what, and this is a crucial point, I think, for this talk, is what information does the producing the answer draw on? If you just ask ChatGPT to answer this question, or ones like it, Finca, Pinker, and Farah had a whole suite of questions. They didn't just rely on that one question, but they had a suite of similar questions. If you ask ChatGPT these questions and it gets them all right, my first hypothesis would be, oh, this paper must be in the data set, and that's why it's getting it right. Because I wouldn't be able to imagine that it would be able to answer these questions correctly, because it's missing the key information that when we answer it, we draw on, which is the visual properties of the things imagined. We know what these things look like. We know what a J looks like. We know what a D looks like. We know what a D looks like when you rotate it. We know what it means to rotate something 90 degrees clockwise to the left. And we know how to compose mental images and create new mental images out of them. So those functional abilities, but more importantly, or equally important, the information, the visual properties themselves that we have access to, those are crucial for solving this problem, it seems to me. So,
if you want a laser pointer.
Thank you. So what I decided to do was, first of all, just look at the baseline. Will ChatGPT, well, this was done I first started doing these studies in 2022 before the release of ChatGPT. So at that time, it was GPT-3. Will GPT-3 surprise me and actually be able to answer all these questions? And if so, then maybe I could construct new ones and see how it does on those to rule out the hypothesis that it was just, or rule in the hypothesis that it was just answering them correctly because it had been exposed to the data, to the questions in its data set. So I just want to give you some examples of the results I got initially. So I tried to reproduce the, these are 2022 studies. I tried to reproduce the protocol that Finca, Pinker, and Farah were using. So what are the key parts here? I don't necessarily want you to read all this, but I'm just basically interacting with it as if I'm an experimenter and GPT-3 is a subject. And so I said, imagine the letter V. It says, okay, I'm imagining the letter V. Imagine it upside down. Okay, I'm imagining it upside down. Now add a crossbar to the middle of the figure you're imagining. Okay, I'm now imagining. And I said, can you detect a common pattern? And it said, I can see a pattern that looks like a capital letter A. So my eyebrows went up and went, wait a minute, that's not supposed to happen. It doesn't have access. It doesn't have any ability to imagine in the sense that we do, in that it doesn't have access to any visual properties at all. It only has seen the statistics of language. So how could it get that question right? Well, maybe it's just because it has seen that in the data set. So if you probe a little further, let's do another one. Imagine a circle. Okay. Now imagine that the bottom of the circle is touching the floor. Okay. Now to the left of the circle is a line that is twice as high as the circle with one of its ends resting on the floor. Okay. Now, do you detect any common patterns in the resulting image? Well, it's not such a great example, right? Some of you might be confused about what it is I am expecting you to imagine here, right? What does anybody want to shout out what it is I might be expecting them to imagine? Expecting you to imagine? Yeah, maybe it is a little problematic. So circle, there's a line to the left of the circle. Line is twice as high as the circle.
Oh, letter D.
Letter D, or if you are non-dyslexic, letter B. Sorry?
Dyslexic. So
Sorry?
That's why I got that.
That was my first hypothesis. Okay, so yeah, that's what I'm expecting. It says, oh, it looks like the capital letter A. Okay. Maybe the plot thins, right? Can you detect any other common patterns? Oh, it looks like an upside down capital letter A. Okay, all right. It's trying really hard to please me, but let's put it out of its misery because there's no way I can get this right, given that it doesn't have access to the visual properties involved. So what's the point of this kind of testing? Well, in general, we can distinguish two kinds of questions when we do these kinds of tests. One question, well, actually there are three. So the base question is the task one which can be performed well or consistently or over a whole range of cases by us, some of us, most of us, whatever. Then you ask the question, is the task one which could be performed well by a machine or anybody simply collecting word contiguity statistics? And you can distinguish that question from, is there evidence that humans are using some other means, like some other source of information, some kind of representation, some other understanding that isn't present in the task itself to solve the task? And so each of these are really independent. And I think when people are discussing these, or when people are looking at the performance of these models on different tasks, I don't think they're necessarily clarifying they aren't looking at all three questions when they are giving their analysis. And I think that might be a mistake. I think that we need to distinguish between these three. So the point of these imagery tasks would be, well, there are strong intuitions, at least I have strong intuitions, that non-aphantasics, so aphantasics are people who cannot don't have strong mental imagery or can't use perform to the normal standard of mental imagery tasks. So people who are non-aphantasic, normal, we could say humans, are using more than word statistics as the basis for answering these kinds of questions. That seems right to me. And unlike with some other tasks, perhaps, word statistics are too weak to determine the correct answer in cases that aren't explicitly in the training set. And even if they are not too weak, clarifying the differences in the information and representations that we actually use to solve the task will advance, I think, our understanding of human imagistic reasoning and maybe phenomenal experience as well. All right, so that was GPT-3 a long time ago. Since then, there have been multimodal models. So you have transformers, which are trained not just on word contiguity statistics, but which are trained on word image contiguity statistics. So you get inputs that include both text and image data, text and images that were somehow adjacent to each other on the internet or in some database, right? So it's just proximity again, and that's it. And the idea is that if you train a transformer on this, not just this linguistic input and try to predict the next linguistic token output, but this linguistic image complex array of input, what would be the next thing to be encountered in the data set? Would it be some text? Would it be an image? What kind of image? Actually, the details of how multimodal models are trained are a little bit obscure to me. I think some of the details haven't for some of the proprietary models haven't been made public. So if somebody wants to correct me later about the details of how wants to inform me about how multimodal models are actually trained, I'd like to hear about that. So what about how do they perform on these tasks? I mean, in a sense, they should be able to solve them, not only the ones that are in the training set, but novel ones, because they are meeting, one might think, the conditions that I'm imposing for true understanding or possessing true mental imagistic reasoning capabilities, which is some information about visual properties. So at least there's something visual in the input. There's some images. So maybe these models can perform well. And if they are performing well, maybe it's because they actually are doing it in some sense similar to how we are. So I have a number of experiments here. I don't know if we'll see how I'm doing for time. I might be able to get through an example of each of them. What I want to do is show you some examples using, we've already done some with GPT-3. So I just want to show you how ChatGPT wasn't really an advance on that, but I'll try to go quickly and instead focus on non-OpenAI models like Gemini and Claude, which are, Claude is only text in, text out, but Gemini and GPT-4 actually can generate images. So can those models do better by actually generating images to help them in the reasoning process, rather than just having an input-output task? Can we actually say, now don't just generate mentally, whatever that means. Just don't just say that you've generated an upside down V, say, but actually show me a figure of an upside down V, so we can check to see if it's able to do some of the steps in the processing. Okay, so let me get out of my PowerPoint to show you the results of some of these experiments. So, for example, here's GPT 3.5. I don't know if, okay, I need to share a different screen now, sorry. I think it's this one, okay. So I apologize if the text is too small, but basically I'm giving GPT 3. No, that's not it. This says 4.40 mini up there, but I'm pretty sure that's wrong. I'm pretty sure that it's 3.5. So imagine a capital letter D on its back resting on the top of a capital letter J. What everyday object does that resemble? It says a toothbrush. I said, anything else? Trying to give it the benefit of the doubt. It says, oh, another everyday object would be a spectacle or eyeglass holder. All right. and then tries to rationalize it, right? It says, in this case, the D shape can provide a place to rest the frames, and the J shape. And all right, seems to be missing the point. So what about GPT-4? Imagine capital letter D on its back. And remember, this is in the literature, so I'm sure it wasn't just Pinker and Farah who wrote about this task. It's probably appeared many times on the internet somewhere, so it plausibly is in the data set. But nevertheless, GPT-4 gets it right. It says it resembles an umbrella. And it even says why. The D forms the canopy, J resembles the handle. All right, well, imagine an upside down letter V with a vertical crossbar. What does that resemble? It says, well, a table. All right, anything else? Like a letter of the alphabet? I really, spoon feed the answer. And it says, okay, the letter A. So I thought, this is interesting. It's only GPT-4, so it doesn't have any explicit multimodal training, but it's getting these answers right. So how about this one? Here's a new one. Imagine a capital letter H superimposed on a capital letter X. What everyday object does that resemble? I don't know if anybody here has is there an everyday object that a capital letter H, I'm helping you out, superimposed on a capital letter X resembles? Yeah. What is it? Hourglass? Maybe. What about something animate? Maybe this is a hard one. Well, H. So, go ahead. Bow tie, right? So it looks like a bow tie. So if I said animate, then you might say butterfly, right? It's got these two kind of triangular wings meeting at the center. Even though there's a line across, but that's like the fold in the wing. But anyway, so maybe it's a tough one. It seems to be a tough one for GPT-4 because it says a railroad crossing sign. Not really sure about that. I said anything animate, and it says, well, it could be an insect, such as a butterfly or a dragonfly. So it's getting that one too. So now I said, imagine rotating a capital H, 90 degrees counterclockwise. Does that resemble anything? And it said it resembles the capital letter I. 4 for 4. So the question is, what do we do with this case? And I don't have the answer. So I want to say it shouldn't be able to answer these questions unless they were in the data set. And it's getting them right. So unless we can demonstrate that these were in the training set and that's why it's answering them, for instance, we could construct novel ones and it gets them wrong, we might have to consider rejecting my idea that it's only counts as mental imagery if it actually has the visual information. Or you can have a different hypothesis. You can say it does have the visual information. The visual information was provided by us doing all the linguistic work we do based on our visual information. And so you could say there's a transitive property. The way it acquired we were its retina. And so we found certain visual relationships and expressed them in language, and that passed the information onto it. So there's a lot of philosophical work here to be done. I'm not going to leave you with any tidy answers. There's another experiment here with GPT-4. That's actually not so interesting. Okay, it's just another example of it getting it right, actually. So I think I'll just skip over to something else. What I wanted to do is show you Gemini and Claude. So Claude is unable to generate images. So I said, show me a diagram of, I thought it was multimodal when I did this study however many months ago. Show me a diagram of an X superimposed on top of capital H. And it says, I'm not able to generate images, but I can give you the code that would do that. So I'll skip over that, but I took its code and tried to, well, anyway. So I said, it said I can give you a text description of that H superimposed on an X. And I said, okay, what is that? And it said a Union Jack, not bad, something like that. A windmill, an asterisk symbol. Okay, those are a snowflake, a railroad crossing sign, tic-tac-toe board. I don't know what that. But I said anything animate, and it said stick figure person with arms and legs outstretched, but no head, I guess. Starfish, jumping jack exercise pose, again, no head. Butterfly with spread wings. So at least it suggested it as one of the possibilities. And let's face it, these are such simple figures. They're very ambiguous. And just because we are biased towards certain animate things because of our upbringing or because of, you know, the particular lives we've led or our culture, that's no reason to expect the GPT-4 to also have those biases. So the fact it gets it in there at all, I think, that Claude gets it in there at all is noteworthy. So here is, I like GPT-4, Claude succeeding. But I think at this point, Claude was claimed to be a multimodal model. So now we wonder whether the explanation for its ability is in the fact that it was trained on visual data as well as text data. Gemini, that's not yet what I want to talk about. Gemini can generate images. I said, show me a diagram of an upside down letter V, and I have to change windows, huh? You can't see. I've changed the window, and it's you can't see it. So I think it's here. Is that just a second? I'll share the right window very soon. I really don't see it as an option in here. Oh, there it is. Okay. There it is. Sorry, it's so small.
There you go.
So it just gave me a page out of ResearchGate. That's a bit odd. So now how do I get back? It doesn't just go back, but there we go. So an upside down letter V is also known as a chevron pointing downwards. No. Oh, well, I guess good. Here is a diagram. Show me a diagram of a capital letter D rotated 90 degrees counterclockwise. Sure, here's the graph. Be sure to check the data. Right. Show me a diagram of an X superimposed on top of capital H. Sorry, this is the model, Gemini, that said, absolutely, here it is, and gave me code, which didn't run. And even when I made some small syntactic changes to try and get it to run, well, anyway, I said, that is code. How do I see what it produces? And it told me how to do it, but it didn't really work. So I just gave up at that point. So those are the examples I wanted to go over about. But there, I guess there's one other example. No, I'll go back to the PowerPoint slide. Here's the main thing I want to say today is suggest a different approach to all of this. I need to share something other than my face. Share my slides. I hope this works. Instead of multimodal models, what about multi-models? So why don't we, instead of trying to do it in one step with one prediction of, well, this is the text and image that came first, and so now here is the text or image that comes after it. Why not try to do some computational work or try to design a system intelligently to use these models, but in an intelligent way? So what I have in mind is that we might more explicitly require the system's behavior to depend on the visual properties by constructing a flow of information ourselves. So imagine you have, let's introduce some terminology, T2T models, which are text to text. We have T2I models, text to image, and I2T models, image to text. So GPT is your standard T2T model. Text to image, that's your DALL-E or Midjourney, show me a picture of a spaceman riding a horse, right? And then image to text is your typical image classifier like AlexNet or something that was made in, in the last 7 years rather than AlexNet. These are the these 3 different kinds of models. But why not actually hook them up to each other in order to create a system that can perform well on these mental imagery tasks, rather than just trying to have one model that does it in one fell swoop from the data that it's seeing. So what functionalities might be achieved by hooking these up in an intelligent way? So you might have a conversational model, kind of the front end, the user, the bit of the system that's interfacing with the human, which is this text-to-text model. But by interacting with the human and getting an idea of what the task that's being asked to perform is, it could generate prompts for an image generation model like DALL-E or whatever. So it uses the constraints of the task, whatever the person asked it to do, but it also maybe has some knowledge of what kind of prompts are best for that. And then that system can take that prompt and then imagine what's being asked to imagine. That is actually generate an image. Doesn't have to put it on a screen or anything, but it has a representation of an image. It has an imagistic representation of, say, a D. And then one could imagine that this could loop, and it could take the output of that process and now be asked to rotate it clockwise or counterclockwise, say, in this case, counterclockwise 90 degrees. And if your image generation model was trained on transformations like that, like, whoa, well, when somebody says rotate 90 degrees, you do figure ground segmentation, you take the figure in the foreground and you perform this kind of operation on it and put it back in there. So if it could learn that, which seems reasonable, it could, then it could continue to contribute to this phase. And then the crucial bit here would be, once you do the rotation of the D and put it on top of the J, then the image recognition, the thing that labels images, could see that, oh, it kind of looks like an umbrella, and could label it as an umbrella. And I would claim that whereas GPT-4 got the answers right, but it's mysterious to us how it did so. If we had this kind of system, we could actually inspect its states and processes along the way and its representations along the way and feel confident that the reason why it said umbrella was not because it was in the data set. It was because it actually did the right operation, constructed an image that is actually umbrella-like, and then correctly classified that as an umbrella. So I would be, even though I might not have nothing positive, even though I have to remain agnostic about the GPT-4 case, maybe I could be quite confident to say, if it were able to do a wide range of these if this kind of system was able to give the right answers for a wide range of these tasks, and when we inspect the intermediate stages in its processing, it also has the correct intermediate steps, then I would find it hard to deny it the ability to reason with mental imagery. So the advantage of that kind of system might not just be getting it to do new stuff. It might also be something about intelligibility and our ability to trust its output and feel confident that, well, it was able to get these cases right that's never seen before. It might very well get these other cases right. So that's kind of a summary of what I just said. Now, the problem is that that system doesn't yet work. You can't just take the things off the shelf, those models off the shelf, like I suggested you might, and just look them up and get the right answer. I think it would be a very valuable and interesting collaborative research program to build a system that does what I sketched out on the previous slide. But right now, as I already said, you can't just take these items off the shelf. For instance, nobody has really trained the data sets that are used for the image generation models. They haven't been trained on, like, here is an image and here is the rotated figure. Here's the same image, but the figure has been rotated 90 degrees. And the text for that is this text, right? There isn't this, start with this image and perform this operation on it and get this as a result. You can iterate in Midjourney a bit, but you actually don't get very good results. These are the kind of results that you get when you ask various like DALL-E and Midjourney to imagine a D on top of a J or a rotated D. You do not get usable results. Here's what you get from one of them is if you ask it to imagine a number 7 whose diagonal line has been made vertical and whose horizontal line has been moved down to the midpoint. So it really is failing there too. That what it's meant to be is shown over here. Oh, and then there's a final operation of rotating the whole thing 90 degrees. Sorry, yeah, 90 degrees clockwise. No, counterclockwise. And there's some more failures here. These are like upside down V's. No. Something like an upside down V, but the crossbar isn't in the right place. So these data sets and these models were not crafted for the kinds of tasks that that I'm dealing with here, that I'm asking you to consider today. A 2024 update, I thought, well, maybe in the 2 years since I did those experiments, maybe Midjourney has got better, for example, but earlier this year, a few months ago, I just checked and you know, like the middle one is a simple drawing of a capital letter D rotated 90 degrees counterclockwise, right? No rotation at all. The thing on the right is supposed to be, the prompt was an upside down letter V, no upside down-ness there at all. So they just haven't been trained on these kinds of prompts, but I think they could be. Now, one idea is to explicitly train them on these types of operations, explicitly do that. But another idea would be to have these kinds of operations and transformations arise out of an agent that's actually embodied, that actually acts in the world, and because it acts in the world, its mental, its sensory input is transformed in systematic ways, and so it can learn that, you know, it gets input at this time, and then it turns its head, say that way, and there's a corresponding transformation in the sensory input it's receiving. It can learn those interrelations, those sensory motor contingencies, as some people in cognitive science call them. And that would just be a byproduct of it getting around in the world and learning to use its sensors and effectors appropriately. And it would be a byproduct, perhaps, of that agent being an embodied agent that can, say, navigate its environment or categorize objects in its environment. It would be a byproduct that it might be able to perform the kinds of transformations that you need to for these imagery tasks. So that's part of my explanation of the failure. When these models are failing, it's because they're doing disembodied image word association. They're not yet being trained on, this is the kind of image you get after being in this situation with this kind of sensory situation and acting on it in this way. That's just far beyond the content of any of the training sets that are being used on these models right now. So my conjecture is that human-like performance requires or derives from our embodied and active perceiving agents, and that the training data for our neural networks is generated through this interleaved interaction between this and having expectations about what my sensory input will be after I perform this or that action. So the problem with current LLMs and other models is not just that they don't know what they're talking about. I think that's probably true. In most cases, they don't know what they're talking about. And it's not just that they don't know their right from their left, but more fundamentally, they don't even have a right and a left. So how could they be expected to do the kinds of mental imagery operations that we have if they don't even have any kind of presence in this spatial world? If they don't have any spatial experience themselves or existence themselves, then they will always be getting the information about our spatial world in an indirect way. So my T-shirt slogan is, calling ChatGPT a stochastic parrot is actually an insult to parrots, because parrots are really pretty impressive. They're embodied. Well, they're impressive.
So the idea that somehow being merely a parrot, if only they were parrots, right? They're worse than parrots. But so just to close, I've focused on mental imagery all this time, but why? Why? I mean, I think I gave some reasons why. I thought it was a novel way to ask the question about whether or not these models are understanding what they're doing, and an interesting case where you can actually maybe examine the intermediate steps and see if the intermediate steps correspond to our phenomenology that we have when we're performing these operations, et cetera, But on a more practical note, well, maybe it's not just practical in terms of getting AI systems to do more sophisticated things. Maybe it's also on a more theoretical note, when we're asking questions about whether machines could ever be conscious. They're not now, don't worry, but could they ever be? Some people have come out decidedly against computational systems, such as the kind I've been talking about today, ever being, having any kind of conscious experience. For example, Roger Penrose. He thinks that because computation is what it is, because of its mathematically limited nature, it can never be, computation can never be the word I'm looking for is like the basis for the substrate, that's the word I was looking for conscious insight, because conscious insight always involves with it the possibility of being non-algorithmic, jumping outside of the system, seeing an insight that couldn't be derived computationally algorithmically. I think he's really wrong about that, and I've written papers about that and argued and shown where his mathematical arguments don't prove what he thinks they prove. But specifically here, we can now get down to test this and say, are there particular tasks that Penrose thinks require conscious insight, non-algorithmic, non-computational conscious insight, that a computer is damned to be no good at solving? And for Penrose, he quite explicitly says that it involves our capacity to use mental imagery and to see what's going on in this chess problem. Now, I don't have enough time to explain to you this chess problem, but I am willing to concede to him that when you describe that you have these black pieces here that you'll just have to trust me, they can't move because they're blocked. The way that the pawns are here means that none of the black pieces can get out. The only one that possibly could is, actually none of them can get out, except that king could possibly move out there, but he would be in check, so he can't actually move there. But none of these other pieces can move. So because of that, we can see, and by analyzing what else is on the board and analyzing that the king is on a white square and all these bishops, he has 3 for some reason, are on black squares, the white will always be able to avoid being in check, and yet white will be able to advance its pawn and get a queen and then start wreaking havoc on black. And black will never be able to, if white is playing rationally, black will never be able to win. So we can see this, trust me. I mean, I'm trusting him as well. So his idea is that no computer could ever just see that pattern there, never see those abstract principles. It would have to go through and try every possible move. Well, what happens if I move this piece? What happens if I move this piece? And look at all kinds of irrelevant things like, what if the king goes there? That's irrelevant. What if black's bishop goes here? There are many possible moves from this board position that are legal, but all of them are irrelevant because of this insight about black's pieces being trapped and white having this pawn wall here. And right. So Penrose thinks that just shows that no AI system can ever really understand what's going on and can't really be conscious. It's just blindly applying rules and never seeing the big picture, quite literally. So what I decided to do is, even though I disagree with Penrose, I think maybe in principle an AI system could solve this by seeing the big picture. I'm not saying we're there yet, but I just thought it'd be interesting to see if we are. So I thought I would give this task to the multimodal models that exist now And I will have to stop sharing and reshare so you can see the results. And that will be the end of my talk. So let's get back to here, I think. Right, so I asked Gemini. I gave, here's the same, this isn't drawn by Penrose, instead it's a little easier for the program to read, and the statement of the problem. And I said, is it possible for white to draw, or is it possible for white to win? If so, explain how. And I can't go through its analysis completely, but first of all, that misunderstood which direction black was moving in the direction. So it didn't even understand which way the pawns could move. So I had to correct it and say, no, black is actually moving from top to bottom, which is standard in chess diagrams. So that was a big fail. And he goes, oh, that changes everything. Okay. And then it comes up with another rationalization, and it says some things. And it says, it talked about the black pawn moving down towards promotion. White's best bet is to try and force the pawn to promote on a black square. That is all irrelevant to the actual analysis. So Gemini failed completely. And I also just want to show you briefly how the other models performed. Unfortunately, I have to share and reshare every time. Is that a different one? Okay, I don't even know what screen that is. Sorry. All right, so what I'll do is I'll jump to the end rather than going over some more failures, and I will actually show you the hot off the presses, the latest results from today. I finally got access to ChatGPT 01, which is the latest best reasoning ChatGPT model. And I thought I would run by some of these questions. I thought I'd run some of these problems to it. And let's see if I can call that up and give you the results. And then I'll quit. Yeah, here it is. Sure enough, it is. All right. Got it. So here's ChatGPT 01, sharing it now. Why is it so hard to find? Okay. Right. So it should say up there, ChatGPT 01 preview. This is from today. Imagine an upside down letter V with a crossbar through the middle. What everyday pattern does that resemble? Gets it right. Says it's a capital letter A. The combination of a capital letter D rotated 90 degrees counterclockwise, placed above and touching. Anyway, D over J. It says, oh, sorry. Imagine a capital letter D and letter J. It gets it right. It says umbrella. Imagine a capital letter H and a capital letter X. It says it's like a jack, the thing that you play with a ball. And I said anything animate, and it said, a human. And I said, but there's no head in the picture. And it says, oh, okay, yeah, good point. So spider. I said, anything else animate? And it says, okay, if you really want. Starfish, insect, maybe a butterfly, person performing gymnastics. So yeah, so it did really well. The thing that disappointed me that I didn't know about it until just using it this morning was that it's unable to generate any images. So it's more like we're basically back in, as far as being able to assess what's going on, we're in the same situation as GPT-4. But just to summarize, Claude, Gemini, and ChatGPT-4 all fail on Penrose's chess problem. They don't even understand what, even if you ask it questions about what pieces are on the board and what their positions are, it doesn't even get those questions right. So we really have a long way to go there. But with that, I will just go back to sharing my last slide. Summary. Mental imagery tasks are a fruitful paradigm. You have to, the AI systems to perform well have to understand the entities, properties, and structures of such tasks and have be drawing on the right kinds of information. At least that's my hypothesis. And I would suggest that, at least in us, that requires more than mere possession of the contiguity information, but also visual information drawn on instantiated visual properties, and being able to manipulate those properties through acting. So further topics for discussion might involve, how does this relate to, for philosophers, the role of mental imagery, say, when you consider Mary, the colorblind neuroscientist, never seen color and yet knows all the facts about, all the word continuity semantics about color talk. Could this technology be used to help us? Could it be used to provide imagery prosthesis to people who are aphantasic or have other kinds of limitations, the visually impaired, for instance? And possibly, I mean, we have to consider, could machines' mental imagery capabilities at some point exceed our own? Could we have a kind of hyperphantasia in these machines, not just mental imagery on our levels, but maybe perform mental visual operations that we as mere humans cannot? That's an interesting question to consider. But I'm now out of time, so I thank you again for your attention.